This mini byte is linked to Unit C4 OCR Gateway Electronic Configurations for GCSE Science. When in the previous video we looked at the numbers found on the periodic table to help calculate different subatomic particles, one of the numbers we looked at, the smaller of the two numbers, is called the atomic number. Now, when we looked at the atomic number, we focused on the fact that the atomic number is the number of protons, number of positive protons found inside the nucleus. However, because atoms are neutral overall, the number of positive protons are the same as the number of negative electrons. So that means that we can use the atomic number to help us decide how many electrons a particular element actually has. Electrons are arranged in shells, and in the example that I've got on the left hand side, the first shell is actually in the centre, and the second and the third shell work basically from the centre to the outside. The shell that's nearest the nucleus has the lowest amount of energy, and the shell that's furthest from the nucleus, called the outer shell, has and contains the highest amount of energy. We can represent electrons by using either dots or using crosses, and that will come in particular importance when we look at covalent and ionic bonding. I'm going to use crosses, and when it comes to positioning, there are certain ways I'm going to teach you that are the best ways to position your electrons. The first shell, shell number 1, can only contain a maximum of 2 electrons in the shell. Shell 2 can contain up to 8 electrons, and the way I recommend positioning your electrons is like this: 1, 2, 3 and 4, and then pair 5, 6, 7 and 8. This will help you later when it comes to ionic and when it comes to covalent bonding. In the third shell and in the fourth shell up to the element calcium, we can use a similar 1, 2, 3, 4, 5, 6, 7 and 8. So shell 1 is the only shell that can only contain 2 electrons. Shell 2, shell 3 and shell 4, remember that they can contain up to 8 electrons. So let's have a look at the example of oxygen. Again, I'm going to use crosses to represent where the electrons are. The first thing you should notice on the periodic table for oxygen is the atomic number is 8, which means there are 8 electrons in total inside each oxygen atom. So when it comes to actually positioning the oxygen atoms, what you need to be able to do is to decide how many there are in each particular shell. You always start in the centre and you build up from the centre to the outside. 2 electrons goes in the first shell. We started with 8, so if we've already used 2, that will leave us with 6 electrons for the second shell. 1, 2, 3, 4, 5 and 6. In this particular example, we wouldn't actually need the third shell at all. There are only 2 shells in oxygen, 2 electrons in the first shell and 6 electrons in the second shell. We can write it as what's known as an electron configuration. An electron configuration just shows us how many electrons are in the first, the second, and if there are more shells, the third and the fourth. In this particular case, we can write the electron configuration as 2.6. This tells us there are 2 electrons in the first shell and 6 electrons in the second shell. Have a go at nitrogen. Okay, so the first thing you need to look at is the atomic number. That will tell us how many electrons there are. First shell, we can only fit 2 electrons. If we started with 7, we're going to take away 2, which leaves us with 5. As it's not greater than 8, we don't have to go into the third shell. The only time you'll need to go into the third shell is once you have positioned 2 followed by 8 electrons. So if you have over 10 electrons, you'll go into the third shell of an atom. If you look at this example, 2 electrons in the first shell, 7 electrons in the second shell. This particular element is actually fluorine. And if you look at the periodic table, there are certain things that we can connect to the periodic table that help us to use the periodic table in a way that gives us the maximum amount of information that it can provide. In the case of fluorine, fluorine is found in a group on the periodic table. If you remember, the groups are the columns on the periodic table that are numbered 1 to 8 or 1 to 7 and then 0 on the end. And in the case of group 7, they're known as the halogens. This particular element is found in that group, in group 7. Fluorine, chlorine, bromine and iodine. In the case of the period, which is the row, it's found in row 2 or period 2. Now what you'll notice is a connection between the numbers I wrote down and the structure of the electrons in shells inside that particular atom. The group number connects to this number here. The group number connects to how many electrons are found in the outermost shell of any atom. So every single element that is found in group 7 will have 7 electrons in their outer shell. This is why group 7 react in a very, very similar way. In the case of period 2, the 2 links to the number of shells in total. So in the case of fluorine, which is found in period 2, it has 2 shells in total. So let's have a look at this particular example. If we use a similar way of thinking about those numbers. We said a second ago that the group number corresponds to the number of electrons in the outermost shell. So in this particular case, this element must be in group 1. Now there are lots of elements in group 1 on the periodic table. If you have a look, there's lithium, there's sodium and there's potassium. When we look at the period, however, it gives us that little bit more information to pinpoint which particular element that you have. In the case of the period, we can see we have 1, 2, 3 actual shells inside those atoms. If there are 3 shells, it would be found in period 3. If you have a look on your periodic table, what you'll find is the element that is in group 1, the element that is in period 3 is in fact sodium. So this particular configuration is the electronic configuration for sodium, the element. So let's have a look at a fairly recent exam question. So element X has the electronic structure 2882. The question asks, how can you tell that element X is in fact calcium? Now the answers that I've seen with this particular question tend to focus on the structure and looking at the fact there are 2 electrons in the first shell, 8 in the second, 8 in the third and 2 in the fourth. The first thing that people can identify is the fact that in total there are 20 electrons. That's completely true, but it wouldn't be sufficient enough to just say because it has 20 electrons. If you talked about the fact that there are 20 electrons, and there are 2 ways in which you could potentially write this, and the fact that 20 electrons, calcium is number 20, that's one potential way. Or because there are 20 electrons, the atomic number is 20. That would give you the ability to access that particular mark. So you've got to link it to the periodic table in some way. However, there is another way of potentially answering the question, something we've already looked at before. We can look at the configuration 2882 and we can straight away see 2 key things. Firstly, we can see that it has 2 electrons in its outer shell, which tells us that this particular element is in group 2. The second thing we can see is that in total it has 1, 2, 3 and 4 shells, which tells us that it must be in period or row 4. And in that particular case, it would be sufficient enough to have your answer structured, basically saying that the element is in group 2 and period 4.